Hello, good morning, friends. And today we are going to solve uh, NEET questions which is asked in the year of 2022. So, the first question is like this: the displacement time graph of two moving particles makes an angle of 30 degree and 45 degree with the x-axis as shown in figure. Then they have asked us to calculate the ratio of their velocity. That is, if I have taken this first object, so this first object is moving with an angle of 30 degree. So the y-axis they have given a displacement and x-axis they have mentioned it as a time. So we need to calculate this v1 value and one more moving particle, so that is moving with a velocity of 45 degree. So we need to calculate the velocity of v2. So individually we can calculate v1 and v2. Next, after that we can calculate the ratios. So but the problem here is, we know that we in the subject we have studied that the velocity is nothing but a rate of change of displacement with respect to time, but they have not given any displacement value or a time value. But we are good at geometry, we are good at trigonometry. So for that they have given a hint. What that hint is, the mass 1 is moving by making an angle of 30 degree with the x-axis, and the m2 particle is making an angle of 45 degree with the x-axis. So think for a while, with the help of this trigonometry, how to calculate this velocity v1 as well as a v2. So if you have got any idea, uh, then it's good, and if not, not to worry. See, with the help of trigonometry, how we can solve this problem is, so what I will do is, I will draw a slope here. So this slope is making an angle of theta. So this theta is equal to 30 degree here, and even in this graph, so this I can mention it as a theta 2, and this I can mention it as a theta 1. So this theta 1 is 30 degree, and here theta 2 is 45 degree, because this angle and this angle will be the same. So from this slope, what I will do is, I can take ABC. So if I have taken a sine theta value, then the sine theta what I will get here is, this sine theta I will get opposite side divided by hypotenuse. So the here is opposite side is AB and hypotenuse is AC. See, this AB is parallel to this y-axis. So this AB is parallel to y-axis. This AB is representing a displacement. So we got the value of displacement here, but we don't know the value of AC. So this first equation comes sine 30 degree. I can write a sine 30 degree is equal to displacement divided by AC. And now what I can take is cos 30 or cos theta. So the cos theta is what? Adjacent side divided by hypotenuse. So here is adjacent side is BC divided by AC. See, this BC is parallel to x-axis. So this BC is representing a time. So one more value we got, but this AC we don't know. See, we know velocity is displacement and time. See, from this graph, we have drawn a slope here. With the help of slope, we have got the value of displacement and we have got the value of time. Now, what we can do is, uh, now what I can take, yes, exactly what you said is correct. That is we can take a ratio of this sine theta divided by cos theta. So once I take sine theta divided by cos theta, this displacement divided by AC. So here this AC goes here, AC divided by time. So this AC cancel, sine theta divided by cos theta is tan theta. So displacement divided by time taken. So with the help of this, what I can calculate is tan 30 degree is equal to a displacement divided by time is nothing but what I can represent is V1. So this tan 30 value is 1 divided by root 3 is equal to V1. So similarly, what I can do for the second one, also what I will get, tan 45 is equal to V2. So this tan 45 value is 1. So V2 is equal to 1. So if I take the ratio of these two things, V1 by V2, what I will get is 1 divided by root 3 divided by 1. So that is nothing but 1 is to root 3. So this is the second option. So these are all time consuming process. So if you are good at solving such type of problems, then you can directly take tan theta is equal to uh, tan theta is equal to opposite side divided by adjacent side, that is AB by BC. So this AB is nothing but a displacement and BC is nothing but time. So we can directly calculate with the help of this tan theta. See, we are solving a Neet problems, so instead of doing all these things, we can directly use this formula. The next one. So the next one is uh, related to thermodynamics chapter of class 11. So here they have given a 4 graphs. So among these 4 graphs, we need to calculate the work done. So maximum work done. So this PV graph is representing the work done. So here is the piston cylinder arrangement here. So this is a top dead center and this is a bottom dead center. See, the piston moves from top dead center to bottom dead center. See, before that, uh, what we know is work done is equal to force into displacement, and here cos theta I can take it as a cos 0 because the force and the displacement are in the same direction. So here, instead of a force inside this piston, the because of the heat, enormous amount of heat is producing. So because of that, pressure is developing on the top of this piston. So this, because of the force, instead of force, what I can write is the pressure. And the displacement, see here, the piston is traveling from top to bottom. See, there is a change in a volume is occurring. So instead of displacement, what I can write is volume. So cos 0 value is 1. So work is equal to pressure into volume. So this is our formula. So the P versus V graph is representing the work done. So the area under pressure versus volume, gives us a work done. And with the help of this, if the more area under this PV diagram, the more will be the work done. More will be the work done. See here in this graph, this PV graph, this area is small, so we can produce a small amount of work done here. So this cannot be our option. And the third one, this one is a, see here, the throughout this a change in a pressure, the pressure is changing from 1 to 2. See, this pressure is changing, but what is happening? The volume is remaining a constant. Volume remains a constant, means pressure is applying on this piston here, but piston is not making any movement. So if there is no displacement, then we are producing the zero work done. So to do the work done, there must be some displacement. So we are doing the zero work done in this case. So here there are only two options left, 2 and 4. So from the graph, what we can easily tell that, see, this graph is having a maximum area. Under PV we have a maximum area, so this is producing the maximum work done. So one more point here is, I have left this area, I have left this portion. This portion is not representing any work done. So this is because even in this case also, this is representing the clearance value. So here the piston is not make any movement here. This is we call it as a clearance value. So this is not utilized for doing any kind of work done. So here there will be no work done. So I hope all you have understood. Thank you very much.